All right, so it sounds like a few of us were a little confused about creating this graph and doing an assignment kind of like this one, where we were looking at the position time graph and changing it into a velocity time graph. So here we're going to have a velocity graph, which is going to be in meters per second on the right, and that's what we're going to try to create. And we start off with this position graph over here on the left, right here. So to start off with, what we need to do is figure out for each of these sections, what is the slope. So from this point to this point, this would be our section A in this case, or our first section of the graph. And for this one, it goes, and the object moves from 1 meter to 3 meters. So that's a change of 2 meters in the positive direction. And it takes, from this point to this point here, it takes 4 seconds. So what we can look at is what's our position at the beginning, x naught, at the time t equals 0, and then what's our position at the end for this one, what's x final. So our initial and final positions for each of those would be 1 meter and 3 meters. And to figure this out, what we can actually do is look at x final minus x initial to tell us the change in position. And if we divide that by time final minus time initial, this gives us basically this idea of delta x over delta t, which is equal to the velocity. So in this case here, for these 2 points, we can go ahead and fill in some numbers for this equation that we've got so far. So we get our final position is 3 meters minus 1 meter, all divided by 4 seconds minus 0 seconds, because that's the time at the end and at the beginning. And this is going to be equal to 2 meters in 4 seconds. So if we travel 2 meters in 4 seconds, that would be equal to 0.5 meters each second, meters per second. So that was how fast we're traveling from the very beginning here at time t equals 0 to the very end of that first part of the motion at time t equals 4. And so what we're going to do is for the first 4 seconds, we're going to say it's moving forwards at 1/2 of a meter per second. So right here, this is where 1/2 of a meter per second is. So every point along the way, it's traveling at a speed of 1/2 of a meter per second forwards. So you can draw it just kind of like this, just a line across, or a bunch of points across, however you'd like to draw it, something like this. Then for the next few seconds, we've got it moving in this section right there. It travels a distance starts off at 3 meters, it winds up at the end at 3 meters, and we can see how long it's there. So in that period of time, that would be 2 seconds. So here, x final, the final position, 3 meters. The initial position, also 3 meters, because it stays the same position. And time final, in this case, would be 6 seconds minus 4 seconds, because that's the beginning and end of this part of the motion. And so we wind up with 3 minus 3 equals 0 meters in 2 seconds. And if we traveled 0 meters in 2 seconds, our speed is 0 meters per second. So from 4 to 6 in this case, 4 to 6 in this case, we get 0 as our velocity. And then for this one, the last part that we're going to look at is this section from 6 seconds all the way down to 9 seconds. So this is 3 more seconds, and in that 3 seconds, we go backwards by 3 meters. And so what we can do there is say, going from final position of 0 meters minus the initial position of 3 meters, we can divide that by 9 seconds minus 6 seconds, which is the beginning and end of that portion of the movement. So when we look at this, we get negative 3 meters divided by 3 seconds, which gives us a velocity of negative 1 meter per second. And so from 6 seconds on to 9 seconds, we've got negative 1 meter per second as our velocity. And so this is the whole thing here. This is what our graph would look like. We've got a positive 1/2 for a little while, a 0 for a little while, and then a -1 for a little while. And so we're looking to graph these 3 portions of the motion, or in your assignment, those 4 portions of the motion, A, B, C, or A, B, C, D. Positive velocity would mean it's going forwards, like in this part of the graph here at the beginning, part A, and negative velocity would mean it's going backwards. Hopefully this helps.